Thank you for joining us at Coalesce. My name is Elise Papineau. I am a senior analytics engineer at DBT Labs, and I'll be the host of this session. The title of this session is Firebolt Deep Dive, Next Generation Performance with DBT, and we'll be joined by Kevin Marr and Cody Schwarz from Firebolt. Just released some rad merch, and even more excitingly, today they'll be announcing a new DBT adapter and giving us an intro to Firebolt. Before we get started, I just want to shout out that all chat conversation is going to be taking place in the Coalesce-Firebolt channel of DBT Slack. If you're not a part of the chat, you have time to join right now. Please visit community.getdbt.com and search for Coalesce-Firebolt when you enter the space. We encourage you to interact with other attendees, ask questions as they come up, make comments, and react throughout the session. After the session, the speakers will be available in the Slack channel to answer your questions, but we encourage you to post those questions as they come up during the session. Let's get started. Over to you, Kevin and Cody.
All right. Thank you. Hello, everyone. I'm Cody, and I'm a product manager with Firebolt, and I am joined by Kevin, who is head of ecosystem product at Firebolt, where he's working on building out integrations with Firebolt across the stack and specifically DBT. So what are we talking about today? First, we want to spend some time talking about where the data warehouse market is and how far it's come over the last decade and some of the challenges that are still present. With that understanding, we'll tell you more about Firebolt, how Firebolt is different, and why we're building a new data warehouse. And after that, Kevin will give you a sneak peek into the Firebolt DBT adapter and show a demo of DBT running with Firebolt. So looking back, it was a great decade for cloud analytics. The industry made huge strides across a wide range of dimensions that has led to an explosion in data usage, growth of the industry, and likely plays a big part in why many of us are working with data today. We wanted to reflect on a few of the big steps. So Redshift was the first cloud data warehouse released in 2012, and Amazon showed that data warehouses can be SaaS, such that setting them up is just a few clicks and not a multi-month project. And giving the user the ability to scale their warehouse easily provides tremendous value. Databricks leveraged Spark and popularized distributed computing in the cloud, and also made distributed analytics simplified and improved over the MapReduce era. And BigQuery introduced the serverless data warehouse, followed shortly by Athena, which simplified things even further and proved really well suited for some workloads like ad hoc analytics. And Snowflake popularized decoupled storage and compute with a great and easy to use experience that gave the user many of the right abstractions for managing a data warehouse in the cloud. And with all that advancement, ELT became the preferred way to manage transformations. And this was unlocked by all the work done to improve the scale of the data warehouse and the rise of DBT. And we're all here today because of how powerful DBT is and how the pair of a cloud data warehouse with DBT is a total game changer. But all these advances have also created new demands and new data challenges. We expect more from our analytics today, and use cases are becoming more operational in nature and customer facing. These use cases are relying on ever-growing data sets, and terabyte is slowly but surely becoming the new gigabyte. If that's not the case for you, just wait, as it will be. Data velocity increases can quickly lead to a lot more data captured, and more data with more sources means more types of workloads across ELT, analytics, and more. And then there's the rise of data apps. Not only are we trying to analyze more data, but users are expecting faster data experiences. Gone are the days when we're waiting dozens of seconds for queries was acceptable. Standards have been set by the leading organizations in terms of performance and data availability, and customers expect the same experiences everywhere. Few seconds is too slow. Sub-second to single-second experiences are a must, and SLAs and standard across data apps, and users expect production-grade reliability and uptime from data apps. And lastly is cost. Access to more data and limitless compute makes it easy to run up a big bill. Compute costs in the cloud are not going down, so with expanded data and limitless compute access can lead to greatly increased cost. To address the cost challenge, we need a new approach. More nodes is not always going to cut it. So with that, Firebolt was born from a realization that we're just getting started with cloud data and what's possible. And we're here to build a modern data platform for builders of next-gen data experiences. So what do we mean by that, and how do we do it? First, Firebolt focuses on unbelievable speed and efficiency, designed to give data engineers the ability to architect sub-second analytics experiences at terabyte scale. Firebolt does this through indexing and using the most advanced query execution methodology. We'll drill into this more later. Modern cloud native architecture. Recent cloud data warehouses have set the standard and expectation here. You need decoupled storage and compute to get the most out of today's tools and experiences. And Firebolt is fully cloud native with decoupled storage and compute. And Firebolt is built for developers and data engineers. The way we work with data has changed. We now have new processes, tools, approaches, and beyond that, different skill sets and backgrounds are getting involved with data. We're building a data warehouse that embraces these new practices and builds them natively into the Firebolt experience. First, let's talk about speed and efficiency. The reason current cloud data warehouses are slow is that they have to move large partitions or blocks into their compute cache. They have to scan them entirely when the query only needs a small subset of the data. So even though most queries only scan 1% to 2% of the data in those partitions or micropartitions, data warehouses have to move and scan them entirely to find the small number of relevant records. The way we're able to overcome this bottleneck is through sparse indexing. Sparse index points to small data ranges within files, which are much smaller than partitions or micropartitions. These data ranges are the smallest unit that is moved and scanned, resulting in dramatically less data movement and data scans compared to other query engines. So sparse indexing requires sorted data. This is what we call triple F. On ingestion, Firebolt sorts, compresses, and applies sparse indexing on the data. As a user, you don't have to worry about the details or the file format. It's all abstracted for you and managed behind the scenes. When you create a table in Firebolt, you specify the field or fields you want in your sparse index, and the files are physically sorted by them. See the primary index syntax in this code example here. And Firebolt gets even faster with our indexes. We're going to highlight two building blocks here, the aggregating index and the join index. So first, the aggregating index. Aggregating indexes are designed to be an easier way to use the same principles behind materialized views and other rollup methods. In Firebolt, aggregating indexes are another index type that gets applied to the table and optimized at query execution time. They're used when you have a repeating query patterns and you can prepare part or some of the result set in advance. You define them once, can define however many you need on a table, and then the optimizer will pick the best one at query time. Best part, there's no work for you to do behind the scenes. These are automatically maintained by Firebolt. Next is join index. Join indexes allow you to get denormalized scale and performance while using your favorite data modeling methodology. You no longer need to denormalize your table to get good query performance. Much like aggregating indexes, you can build multiple join indexes on a table, and the optimizer will pick the best join index. We can use join indexes to improve query rewrite and really speed up a join. And furthermore, a join index helps replace full table scans with lookups and other operators that are much faster and less expensive. So Firebolt is a modern cloud data warehouse architecture with decoupled storage and compute designed to support all analytics workloads in a scalable and isolated manner. What this means, like other cloud data warehouses, you can load any data and reuse it across any compute, called engines in Firebolt. With a new use case, you can set up a new engine to support a new project without impacting other workloads. And this approach allows customers to start small and add new projects by spinning up a new engine. You can then right-size each engine for the workload based on compute needs. So now, as I mentioned earlier, we're focusing on improving the life for data engineers, analytics engineers, and developers. And Firebolt is designed to help with the challenges that modern data stacks present. First, we believe that data engineers and developers need and appreciate flexibility and control. At Firebolt, you can do everything with SQL, including the management of engines. This gives you great control while keeping things as simple as SQL. Firebolt is also unique in giving you granular control over compute resources, so you can more directly match your workload to its compute needs. And Firebolt is also fully programmable through our REST APIs and our Python SDK and other SDKs coming soon to programmatically create and manage your Firebolt environment with your orchestration tool of choice. But the fact that you're a data engineer doesn't mean we want you to work too hard. Firebolt is also about eliminating the grunt work. Scaling is just a few clicks or API calls away. Semi-structured data is natively supported with Lambda functions that give you great power. Indexes are easily defined and managed behind the scenes automatically, so there's no manual intervention required. And queries are optimized so you don't have to. Lastly, you never have to worry about storage management and things like vacuuming. And so we believe the future is code, where we continue to push the limits on bringing the best practices from software development to data engineering. And there are a few dimensions of embracing a data as code product philosophy to call out. So first is data ops. What data ops means to us is bringing DevOps best practices like version control, automated testing, and first-class environments to allow teams to collaborate more effectively, experiment, and gain confidence before changing their pipelines. With data, as we all know, this gets tricky, and rollback is much harder than in software development. But a lot of these current challenges can be improved. This also includes better enabling CI and CD pipelines and data, something that DBT is really at the forefront on, but overall, there is still a ways to go. And DBT has inspired many teams to adopt version control, add testing, and use different environments for production and development work. Automated end-to-end testing, which helps you quickly identify potential negative downstream impact of any change. A data warehouse that is more aware of your tests can help streamline your workflow and improve the experience for data engineers. And we believe the days where you manually provision your data warehouse infrastructure, objects, and roles will soon be gone and will be fully replaced by declarative tools like Terraform or more imperative infrastructure as code tools like Pulumi. We are committed to making Firebolt the easiest to deploy via code with native experiences here. And last but not least, we believe in code modularity. Being able to define templates and reusing code elsewhere is a key building block to a long-standing platform. That's why our bet is on DBT. Code modularity helps in breaking down complex models, test individual components, and debug in isolation, and reuse those units of work downstream. So with that, I'll hand it over to Kevin to talk about the Firebolt DBT adapter.
Thanks, Cody. So let's, I guess we'll switch it over to my screen share. And great, thanks again. It's with great pleasure that I get to introduce Firebolt's brand new DBT adapter. The ecosystem team at Firebolt has been hard at work building this for the last couple months. And we're just really excited to be able to contribute this to the DBT community, and also to obviously provide the benefits of DBT to our own customers. What I want to do with y'all is walk through the highlights of the adapter and also actually show you a sneak peek, jump into the actual product itself, and do a live demo. So first, the goal with the DBT adapter for Firebolt wasn't just to check the box and then move on. We really want to continue to invest in this integration and this relationship so that we're materially enhancing the DBT experience when you're using it on top of Firebolt. And even today, we're just getting started, but there are three things specifically that I wanted to point out that we're really proud of. And first, and perhaps most obviously, is that Firebolt is really fast, right? That's our primary differentiator. And if you think about it, every analytics engineer and every data engineer, their primary job is just making sure that they're giving the best data experience to their end users. And the speed at which queries get back to you is a really big part of that experience. Second is how indexes are handled in the adapter. So you saw from Cody's presentation, we have some novel indexes that help us get to those really fast queries. And we've baked those into the DBT adapter in a very native way. I'll talk more about that in the following slides. And then third, perhaps this is not a differentiator per se, or it's not unique to the Firebolt adapter, but we're really big fans of the DBT external tables package. in DBT because it actually extends its scope of operating beyond just, I'll say, intra-database transformation, right? DBT external tables allows you to actually do the ingestion part as well into the data warehouse by actually reading the data from S3 and loading it into external tables. Firebolt itself also has external tables, and so this was a really obvious integration for us. And we're really proud that we have this feature, which was not at all a hard requirement from our first release. So I talked about indexes. So remember these from earlier, we have our aggregating indexes and join indexes. This is just examples of the DDL you would use in Firebolt to create these things. And when you're using DBT, you can do it the DBT way. So if you're familiar with DBT, this should look familiar to you, but now we have these novel proprietary index types baked right into the model config. So obviously by having this, it's version controlled. DBT will take care of all the DDL. It'll take care of all the lifecycle management of these indexes when you drop the tables and rebuild them and all of that. But I think what's really interesting is that the way we handle aggregating indexes. So in Firebolt, an aggregating index is conceptually similar to perhaps a materialized view with query rewrite. But we decided not to expose this as an actual relation or an actual table. It's actually exposed as an index in Firebolt, which we think is actually conceptually better aligned with the way that you're thinking about the purpose of a materialized view if it's just to accelerate queries. Indexes should be for accelerating queries, and they shouldn't add noise to your overall data schema or the dimensional model that you have. And so likewise, that concept is parlayed into the DBT experience as well. I don't have to create additional models to express aggregate indexes. Instead, I just add them as indexes like any other index. And my DAG doesn't have these materialized views adding noise and taking away from the pure dimensional model of my. Great. So with that, you might have noticed I'm sharing my whole screen. I want to walk through a demo, and I'm going to jump to my next tab over here, which is actually Looker, which is near and dear to my heart. I used to work at Looker. I did product management for LookML, the data model, which I know a lot of DBT folks out there are familiar with, but I'm not here to do a demo of Looker, obviously. And the reason I have this open is just to acquaint you all with the data set that I'm going to be using, which is an ad tech data set. It's actually real data. We obfuscated it. It was donated to us by one of our customers. And it's a pretty big data set. And I have a dashboard here. In this demo, we've turned off all caching in Looker, so I can simply just hit the refresh button, and all these queries are going to run in Firebolt in real time. You can see them go from faded to full resolution there, or full clarity as the queries refresh. I can go in here and I can change the filters. Again, these are obfuscated values, but say I want to slice this over entirely different media source over this ad tech data, I can do and just update it. And I'm getting very live feedback on this massive data set. Again, all powered by Firebolt under the hood. And I'll jump into the Firebolt UI itself so we can take a look at this data a little bit more closely. So here I have, I'm in the Firebolt app. On the right, I can see my schema, and I can do, let's take a look at how big this LTV table is. So I'll run this. I always find it funny how we round to the nearest millisecond. So we get 0.00 seconds, but it's 32 billion rows in this table. And if I actually show the tables, you can see the size of it. So I'll go to the bottom of this result. If you look at our LTV table here at the bottom, the very bottom of the screen, you can see the size uncompressed. So it's 17 terabytes, actually tebibytes uncompressed, and then compressed down to terabyte when it is compressed. And we're crunching through a good amount of data here. And again, this was just one of the queries I copy and pasted from Looker, which I can run here just to show you the actual measured runtime. And we're returning these queries in about 0.19 seconds. So this is all, again, powered by F3, powered by sparse indexes, and all of the primary indexes, join indexes, ag indexes that we have in Firebolt. Anyways, let's talk about DBT now for a second. So with all of this data that we have in here, here's the DDL that we use to populate this demo. Of course, we ingest data first using external tables from our S3 buckets. From there, we create fact tables. I'm going through this quickly. Fact tables and dimension tables and our indexes and all of that. This is pretty standard looking DDL. But if I hop into DBT, which I'll show you our project in Ada. So here's my DBT project for the demo. And again, I can see these familiar tables that we had that we were analyzing in Looker, now here modeled in DBT. And again, I have my account table with my join index. I'll jump to my LTV table, which is a fact table in Firebolt where we've defined our aggregating index. And also we're taking advantage of that DBT external tables package. So here I have some sources defined, what buckets they come from, the schemas. So let's actually go through all this. Let's run it. Let's build it into Firebolt. So before I do so, let's just jump over back to Firebolt app, another tab. I have a brand new database here, has nothing inside. You can see on the right, it's completely empty. So let's first just load in these external tables. So I'm in DBT. I'll do my command to run the external tables. That's plugging away. So there's one, there's another one, and there's the third. Great. So I'll jump back into Firebolt. I'll just refresh this page so I can get the updated schema view. And lo and behold, so here I have my external tables. I can go and take a look at these. Let's just verify we've got the data in there. Select star from, I'll just say account. I like the autocomplete. Great, so I got my data flowing in. And of course, an external table is not the fully optimized table form, so we want to actually get these into fact and dimension tables according to our model. So let's jump back into DBT, and I will DBT run. And now we're taking those external tables, and we're now running through all the DDL needed to create the fact and dimension tables based on those external data sets. Great, so that's all done. And again, I'll jump back into the UI here in Firebolt and just refresh it. Okay, so I've got my new tables, and you can see from my profiles that I didn't show you, I didn't want to show you my password. We've prefixed these table names so you can get developer isolation while you're all working on DBT. So I've added my initials KM to all these tables. I can look at these. Let's look at LTV. So I can look at some of the data that flowed through there. That's great. Let's look at the indexes that were created. Cool, so you can see all those things that we defined in our DBT project. And I can run something like, I had that same looker query. Let's just run this guy. Cool, and again, we're getting that sub-second, this time 0.10 seconds to do some analysis right on this data. So that's hopefully illustrative of the soup to nuts workflow of DBT on Firebolt. Thanks for watching.